An oak beam cut in the year 1220 is still holding up a cathedral roof today. Think about that for a second. That piece of wood has survived kings, plagues, wars, revolutions, industrialization, world wars, and the invention of the internet. Meanwhile, a deck built in your neighborhood 5 years ago is already warping, cracking, and sprouting fungus around the screws. And here's the part that should really bother you. Medieval builders didn't have electricity, power tools, chemical sealants, engineering software, or modern machinery. They had axes, ropes, patience, and an understanding of wood so advanced that modern construction companies quietly abandoned most of it in favor of speed and profit. Because to medieval craftsmen, a tree wasn't material. It was a living structure with strengths, weaknesses, moods, and behaviors that had to be understood before a single cut was made. These men didn't walk into forests looking for lumber. They walked into forests reading them like physicians diagnosing patients. They examined bark texture. They studied the angle of branches. They watched how crowns leaned toward sunlight. A crooked trunk wasn't just ugly. It meant hidden twisting deep inside the grain, and hidden twisting meant future structural failure. Imagine a carpenter today rejecting a shipment of lumber because he listened to the tree and didn't like the sound it made. Medieval woodsmen actually did exactly that. They knocked against trunks with their knuckles and listened for resonance. A healthy tree rang clear. A hollow or diseased one answered with a dead thud. No X-rays, no moisture meters, just experience sharpened across generations. And somehow, they were right more often than modern industrial lumber grading systems. But the strangest part, the real secret wasn't skill alone. It was patience. Medieval builders understood something modern society hates. Materials have rhythms. Trees had seasons. Wood had memory. Drying took years, sometimes decades. Entire cathedral projects stockpiled beams that wouldn't be used until the grandchildren of the men who cut them were old enough to lift them into place. Imagine trying to explain that to a modern developer racing to finish a subdivision before quarterly earnings reports come due. Sorry, sir, the wood needs another 14 years. Yet those slow methods produce structures that outlived empires. And once you begin understanding how these craftsmen worked, the moon phases they followed, the species they selected, the bizarre preservation methods they used, and the reason medieval buildings could flex during earthquakes while modern homes crack apart, you start realizing something uncomfortable. We didn't simply improve construction over time. In some ways, we traded longevity for convenience. We traded craftsmanship for production speed. And the result is that many modern homes are being built with shorter life expectancies than buildings constructed when knights still rode horses into battle. This is the forgotten science of medieval woodcraft, the lost engineering hidden inside beams that still stand after 800 years while ours quietly rot from the inside out. To medieval builders, choosing a tree was not lumber shopping, it was diagnosis. Long before chainsaws screamed through forests and sawmills turned trees into anonymous stacks of identical boards, woodsmen approached forests with the caution of surgeons selecting organs for transplant. Every tree carried clues about its future behavior, and reading those clues correctly could mean the difference between a roof that lasted 50 years or 500. A master timber selector didn't see oak. He saw tension lines, hidden weakness, water stress, growth history, and structural destiny written into bark and branches. They studied how the tree stood against the wind. A trunk leaning too heavily in one direction often meant uneven grain spiraling internally, and spiral grain was dangerous. Wood like that could twist violently after drying, turning a perfectly straight beam into a warped structural nightmare decades later. They inspected crowns, the leafy top of the tree, because an imbalanced crown meant the tree spent years compensating against wind or damage, creating stress patterns hidden beneath the bark. And then came the part modern people would probably laugh at until they saw the results. They knocked on the trunk, just knuckles against wood. A clear ringing sound meant dense, healthy timber. A hollow thud warned of rot, hidden cavities, insect damage, or moisture problems invisible from the outside. It sounds primitive, until you realize modern inspectors still use versions of acoustic testing today. Medieval woodsmen simply trained their ears so thoroughly that they became living diagnostic tools. Some even smelled freshly exposed wood fibers to judge health and moisture content. Forest knowledge wasn't casual back then. It was survival-level expertise passed down across generations. Location mattered too. Trees growing on north-facing slopes were prized above all others because they grew slower in colder, lower-light conditions. Slower growth meant tighter annual rings, and tighter rings meant dramatically denser wood. A fast-growing tree from a sunny slope might produce 8 growth rings per inch. A slow northern tree could produce 40. That density difference translated directly into strength, durability, and resistance to moisture. Medieval builders understood this instinctively centuries before material science gave it scientific language. They also avoided traumatized trees. Lightning strikes, fire scars, storm damage. These were warning signs. A tree could look healthy externally yet contain invisible fractures inside the grain caused by sudden shock. Modern construction often ignores this entirely because industrial systems prioritize speed and volume. Medieval builders couldn't afford that gamble. A hidden fracture inside a cathedral beam wasn't just expensive. It could kill people generations later when the structure finally failed. Think about the level of responsibility involved in that mindset. These men were selecting timber for buildings they themselves would never see completed. A cathedral project might take 80 years, sometimes longer. The carpenter choosing a tree at age 25 knew he might be dead before the final beam was installed. Yet he still selected wood as though future lives depended on it because they did. Modern construction rarely thinks beyond the warranty period. Medieval craftsmen thought beyond their own lifespan. And maybe that's the real difference, not technology but time horizon. We build for ownership cycles. They built for descendants they would never meet. Now this is the point where medieval construction starts sounding less like engineering and more like folklore. Because if you asked a master carpenter in the 13th century when the best time to fell a tree was, he probably wouldn't start talking about temperature or humidity first. He'd point at the moon. Specifically, the waning moon, the phase between full moon and new moon. To modern ears, that sounds suspiciously like the kind of advice someone gives you right before trying to sell healing crystals at a farmer's market. For centuries, historians dismissed it as superstition. But then modern forestry researchers started testing it. And annoyingly for modern skeptics, the medieval builders were onto something. Trees cut during the waning moon consistently showed lower moisture content than trees cut during other lunar phases. Not dramatically lower, usually around 4 to 5%, but in wood drying terms that difference is enormous, because moisture is the enemy of stability. Excess water trapped inside timber creates warping, cracking, fungal growth, internal stress, and long-term structural weakness. Medieval builders didn't know about cellular water pressure or gravitational fluid dynamics in scientific language, but they understood patterns. They noticed that trees felled during certain moon phases dried cleaner, cracked less, and lasted longer. And after generations of observation, those patterns hardened into strict guild rules. Some medieval trade organizations specified exact dates when timber cutting was allowed. Break those rules and you could lose your membership, your reputation, even your livelihood. Imagine getting fired today because you harvested lumber on the wrong moon cycle. Yet those superstitions quietly produced buildings still standing today. The moon wasn't the only factor. Winter mattered just as much. During cold months, dormant trees naturally pulled sap and moisture inward toward their roots for storage, leaving outer wood drier and more stable. So medieval builders stacked advantages. Winter felling during the waning moon produced the driest possible starting material before seasoning even began. Compare that to modern commercial logging operations, which run year-round because mills need constant supply chains. Efficiency dominates everything now. Trees are harvested according to market demand, trucking schedules, and production quotas, not biological rhythms. The result? Lumber arrives at construction sites already stressed before it's even installed. It twists, it checks, it shrinks unpredictably. And then modern builders fight those problems afterward with chemicals, kiln drying, metal fasteners, vapor barriers, and endless corrective engineering. Medieval craftsmen approached the problem backwards compared to us. Instead of forcing wood into obedience after harvest, they tried to harvest it at the moment nature already made it cooperative. And there's something strangely humbling about that. Modern construction often behaves like war against materials. Medieval building behaved more like negotiation. The builders observed what wood naturally wanted to do, then worked with it instead of against it. Today, we demand instant readiness from everything. Medieval craftsmen accepted that some materials simply refused to be rushed. A tree had seasons, wood had moods, and the moon itself became part of architecture long before anyone realized physics was quietly involved. If you brought freshly cut green timber to a modern construction site today, most contractors would probably reject it immediately. Too wet, too unstable, send it back. Kiln-dried lumber has become the modern gold standard because it's predictable, standardized, and fast. But medieval carpenters would have looked at that same dripping, freshly cut oak beam and smiled like someone handing them premium material. Because to them, green wood wasn't a problem. It was an opportunity. Fresh timber carved easier, shaped cleaner, and behaved more honestly under hand tools. A green oak beam could be worked with axes, adzes, chisels, and drawknives in a fraction of the time required for dried wood. Medieval carpenters weren't simply building structures, they were sculpting them. Every mortise, tenon, notch, and peg hole was carefully shaped by hand. Working with fresh timber saved labor, preserved tools, and allowed extraordinary precision. But the real genius wasn't just ease of carving. It was understanding what happened after assembly. Wood shrinks as it dries. Everyone knows that. But medieval builders understood something deeper. Wood doesn't shrink evenly. It contracts far more across the grain than along its length. And instead of fighting that behavior, they weaponized it. A mortise and tenon joint, the classic medieval connection where one timber fits into another, was intentionally designed with future shrinkage in mind. Builders oversized certain areas slightly, drove in hardwood pegs under tension, then allowed time itself to finish the engineering. As the green wood slowly dried over years, sometimes decades, the fibers compressed inward, tightening around the joints with immense force. The building literally locked itself together over time, not metaphorically, physically. Some surviving medieval joints are now so tight that modern restorers struggle to separate them even with power tools. There's no glue holding them together, no hidden screws, just centuries of controlled shrinkage slowly squeezing the structure tighter and tighter like a permanent mechanical embrace. And here's what makes this truly extraordinary. The builders had to calculate all of it mentally. They needed to predict how much a beam would shrink in which direction over how many years under what climate conditions. Get the calculations wrong and gaps appeared. Roofs sagged, structures twisted apart. But get it right. The building strengthened itself for centuries. Modern kiln drying takes the opposite approach. Lumber is blasted with high heat to remove moisture quickly, sometimes in just days. Efficient? Absolutely. But rapid drying creates internal tension. The outer cells dry first and shrink while the interior remains wet, trapping stress deep inside the wood. Later, those stresses release as cracks, warping, and splits called checks. Medieval air-dried green construction avoided much of this entirely because the wood relaxed gradually instead of being forced. It's like comparing someone calmly aging over decades versus someone being rapidly dehydrated under a heat lamp. Both end up dry, but only one remains stable. And maybe this is where medieval builders reveal something uncomfortable about modern life itself. We've become obsessed with immediate usability, instant results, faster production. Faster drying, faster installation, faster profit. Medieval craftsmen accepted slowness as part of strength. They understood that rushing material often damaged the very qualities you needed most from it later. Their buildings survived not because wood was stronger back then, but because patience was part of the engineering process itself. This is the moment where medieval construction stops looking impressive and starts looking almost impossible by modern standards, because medieval builders didn't just dry wood carefully. They waited for it with a level of patience modern economies literally could not survive. Air drying thick oak properly can take roughly 1 year per inch of thickness. Think about that. A beam 12 inches thick might require more than a decade before it reached ideal stability. And medieval builders actually accepted this as normal. Cathedral workshops routinely stockpiled timber, knowing the wood might not be used until their grandchildren were old enough to work the project themselves. Notre Dame's famous roof structure was built from trees that, in some cases, had been felled generations before installation. Entire forests were managed with future cathedrals already in mind. Today, developers panic if a shipment is delayed 2 weeks. Medieval construction operated on timelines longer than some modern governments survive. But here, why they tolerated such absurd waiting periods. Slow drying fundamentally changes how wood behaves internally. When timber dries gradually in open air, moisture leaves the cells slowly enough for the entire structure to relax evenly. Internal tensions dissipate naturally. Fibers settle into stable configurations without stress fractures forming beneath the surface. The result is timber with remarkable structural integrity, elasticity, and long-term stability. Modern kiln drying achieves the same dryness, numerically but not structurally. Heat forces moisture out rapidly, creating microscopic damage within cell walls. The wood becomes more brittle, more stressed, and more prone to future cracking. It's the difference between naturally aging wine in a cellar and microwaving grape juice until the liquid evaporates. Technically, both lose moisture. Only one develops strength through time. Medieval timber yards themselves were engineered systems. Beams weren't simply stacked randomly. They sat elevated off the ground on stone supports to prevent moisture absorption from soil. Spacers separated each layer so air could circulate evenly. Builders positioned stacks according to prevailing winds, creating natural ventilation systems that slowly carried moisture away year after year. Every pile was organized intentionally. This wasn't passive waiting. It was controlled aging, and the numbers are staggering. Properly air-dried oak can test 20 to 30% stronger than kiln-dried oak from the exact same species and forest. Same tree, completely different performance based solely on drying method. Modern builders often compensate for weaker materials by adding more steel brackets, more fasteners, more engineered reinforcement systems. Medieval craftsmen compensated with time. And honestly, there's something almost philosophical hidden inside this entire process. Medieval societies understood that strength and speed rarely coexist naturally. Strong things matured slowly: timber, stonework, craftsmanship, reputation, trust. Modern culture treats waiting as inefficiency. Medieval builders treated waiting as investment. And maybe that's why so many modern buildings feel temporary even when they're new. They were never designed to age beautifully. Medieval timber structures, by contrast, were expected to improve with time. The wood hardened. The joints tightened. The entire building settled deeper into stability year after year, like a living organism maturing instead of decaying. That's a completely different relationship with construction than most of us have ever experienced. Modern construction treats wood like a commodity. Pine is pine. Lumber is lumber. Cut it, stack it, sell it, install it. One species gets forced into dozens of completely different jobs because efficiency demands standardization. Medieval builders would have considered that insanity. To them, every tree species had a personality, a temperament, a purpose. Choosing the wrong wood for the wrong job wasn't merely inefficient, it was reckless. Oak was the king of structure. Massive beams, support posts, load-bearing frames. Anything expected to survive centuries under crushing weight became oak whenever possible. And oak had another hidden advantage: tannic acid. Those natural chemicals made the wood resistant to fungi, insects, and rot. Medieval builders didn't know the molecular science behind tannins, but they knew bugs avoided oak and buildings lasted longer because of it. one material solving both structural and biological problems simultaneously. Elm belonged to water. This wood twisted and interlocked internally so aggressively that splitting it became a nightmare. Try chopping elm firewood, and you quickly understand why medieval builders loved it for wet applications. Wells, bridge supports, water wheels, ship keels, places where ordinary timber would split apart under constant moisture exposure. Elm endured because its grain fought separation even while soaked. Entire cities quietly depended on elm foundations buried beneath waterlogged ground. Then came chestnut, one of the strangest choices by modern standards. Medieval roof framers prized chestnut partly because insects hated it. Spiders avoided it too. Think about the practical brilliance hidden there. Cathedral ceilings remained cleaner because webs accumulated less aggressively. Medieval craftsmen were solving maintenance problems centuries in advance through material selection alone. Ash became Europe's universal shock absorber. Tool handles, wagon components, weapon shafts, spear poles, anything needing flexibility without splintering became ash. The long straight fibers absorbed vibration beautifully. A Viking axe striking a shield transferred less shock into the user's hands because someone understood ash's behavior generations earlier. Baseball bats used ash for centuries for the exact same reason. And then there was yew, perhaps the most legendary wood in medieval Europe. Not because it was merely flexible, but because one single piece of yew performed two contradictory tasks simultaneously. The outer sapwood stretched while the inner heartwood compressed. Medieval bowyers exploited this natural duality to create English longbows capable of changing warfare itself. Entire battles, Agincourt, Crécy, were influenced by the unique cellular behavior of one specific tree species. Think about how extraordinary that is. Military history shaped by forestry knowledge. Meanwhile, modern construction increasingly relies on fast-growing plantation softwoods selected primarily for speed and yield. The same lumber goes into walls, fences, decks, furniture, and framing regardless of wildly different structural demands. Medieval builders would have seen that as wasteful stupidity masquerading as efficiency. They matched material to function with obsessive precision because they understood something we often forget. Nature already solved many engineering problems long before humans arrived. The trick was learning which tree solved which problem. A forest wasn't raw material to them. It was a library of specialized solutions waiting to be understood. This is where medieval woodworking stops feeling like carpentry and starts feeling dangerously close to alchemy. Because medieval builders weren't just cutting and shaping timber. They were chemically altering it using methods so strange they sound invented, until you realize modern science eventually proved many of them effective. And honestly, some of these techniques make modern preservation systems look embarrassingly crude by comparison. Take water preservation. At first glance, it sounds completely backwards. Water destroys wood, so why would medieval craftsmen deliberately soak fresh timber in rivers for months? Because they discovered something remarkable through observation. Fungi and insects don't actually eat wood fibers first. They feed on the sugars, starches, and nutrients inside the wood. Running water slowly leached those nutrients out. The current washed away the edible components while leaving behind dense cellulose fibers far less attractive to pests. The result was timber that became naturally resistant without synthetic chemicals, but the water had to move. Still water caused rot. Flowing water purified. Medieval craftsmen understood this distinction instinctively centuries before microbiology existed. Then there's bog oak, one of the strangest materials ever used in European woodworking. Entire logs buried for thousands of years beneath oxygen-starved peat bogs emerged black as charcoal and hard as stone. The tannic acids from the bog combined with the lack of oxygen to essentially pickle the wood. Some preserved logs were older than the pyramids and still workable. Imagine holding a beam shaped by human hands that died before written history even existed. Medieval builders didn't fully understand the chemistry, but they absolutely recognized the durability. Shipbuilders developed another bizarre technique, controlled charring. They deliberately burned the outer surfaces of planks until the wood carbonized black. That thin charred layer acted like armor. Water struggled to penetrate it. Insects couldn't digest it. Fire itself became preservation technology. Modern Japanese builders still use a similar technique called shu-sugi-ban today, now marketed as luxury architectural innovation, even though medieval craftsmen were already doing versions of it centuries earlier. The details mattered obsessively. Beam ends received special treatment because medieval carpenters knew exposed end grain absorbed moisture catastrophically fast, sometimes hundreds of times faster than side grain. So they rubbed oils, waxes, animal fats, or linseed mixtures deep into exposed cuts to seal them against water intrusion. Tiny preventive actions created centuries of additional lifespan. And then we arrive at perhaps the weirdest preservation method of all, manure curing. Yes, actual manure. Some timbers were buried inside decomposing manure heaps where ammonia released during breakdown penetrated the fibers and acted as a powerful antifungal treatment. Horrifying smell. Incredible effectiveness. Modern pressure-treated lumber uses copper compounds, industrial preservatives, and toxic chemicals instead. Efficient, certainly. But once modern treated lumber decays or gets demolished, it often becomes hazardous waste. Medieval preservation used fish oils, smoke, flowing rivers, natural acids, and yes, cow dung. Somehow their primitive chemistry produced beams still standing after 700 years, while modern treated decks often fail within a few decades. And maybe this reveals another uncomfortable truth. Medieval builders weren't separate from nature. They studied it relentlessly. Modern engineering often assumes technology replaces observation. Medieval craftsmen used observation as technology. They watched what happened over generations and slowly built entire chemical systems out of pattern recognition alone. No laboratories, no peer-reviewed journals, just centuries of careful attention to what survived and what didn't. Here's something that took modern architecture an embarrassingly long time to rediscover. Wood is alive long after the tree is cut. Not biologically alive, of course, but responsive. It absorbs moisture, releases moisture, expands, contracts, breathes with the environment around it. Medieval builders understood this intuitively. Modern construction often tries to imprison it. And that single philosophical difference explains why so many medieval timber structures survived centuries, while modern homes quietly rot behind perfectly painted walls. Medieval buildings were designed around airflow, not accidentally, deliberately. Those huge roof overhangs you see on old European houses weren't just decorative flourishes meant to look charming in postcards. Some extended 3 or 4 feet beyond the walls specifically to control rain splash. Because medieval builders knew water bouncing off the ground was one of the greatest enemies of structural timber. The roof became a shield, pushing runoff far away from vulnerable lower beams. Then came the stone plinth system, one of the simplest yet most effective preservation tricks ever invented. Timber frames rarely sat directly on soil. Instead, builders elevated them on stone foundations or short raised platforms. Sometimes only 4 or 5 inches separated wood from damp earth. But those inches changed everything. Moisture wicked upward through soil constantly. Keeping timber slightly elevated interrupted that transfer and added centuries of lifespan almost for free. Medieval craftsmen also built intentional air gaps into walls and roofing systems. Modern people sometimes mistake these spaces for crude construction or poor insulation. In reality, they were moisture escape routes. Air moved continuously behind structural timbers, carrying away condensation before rot could establish itself. A beam that gets wet occasionally and dries afterward survives. A beam trapped slightly damp for years dies slowly from the inside out. Medieval buildings understood that difference deeply. Windows and doors weren't only placed for aesthetics or light either. They created cross-ventilation patterns. Entire buildings breathed seasonally. Warm air rose through roof spaces. Fresh air entered below. Moisture escaped naturally instead of collecting invisibly inside sealed cavities. Compare that to modern construction, where plastic vapor barriers often wrap entire houses like shrink wrap. The intention is noble: block moisture from entering walls. But when water inevitably does get inside, from leaks, condensation, or humidity, it becomes trapped. The structure cannot breathe. Studies on failing modern homes repeatedly show catastrophic wood damage occurring inside these sealed cavities, where moisture accumulates silently for years before anyone notices. Medieval builders designed for drying. Modern construction often designs for trapping. And here's the ironic part: medieval buildings leaked more air but survived longer. Modern homes are more energy efficient, but many age catastrophically faster. We optimized comfort and efficiency while unintentionally creating perfect fungal environments hidden inside walls. Medieval builders accepted drafts because they feared stagnation more than airflow. To them, moving air meant survival. Stagnant moisture meant death for timber. And honestly, there's a lesson there extending far beyond architecture itself. Systems survive through movement, through breathing, through release. Medieval builders understood that resilience often comes not from sealing everything perfectly tight, but from allowing pressure and moisture to escape before destruction begins. Their buildings survived because they worked with nature's cycles instead of pretending those cycles could be permanently locked out. If medieval builders could travel forward in time and walk through a modern hardware store, one aisle would probably horrify them more than anything else: the nails. Endless boxes of steel fasteners, screws, brackets, anchors, bolts, thousands upon thousands of tiny metal pieces holding entire buildings together. Because medieval carpenters understood something modern construction quietly ignores: metal and wood are terrible long-term partners. Iron rusts. Everyone knows that. But rust doesn't just discolor metal, it expands. And when a nail expands inside timber, it acts like a wedge splitting the surrounding fibers apart from the inside. Every crack becomes a pathway for moisture. Every rusted fastener becomes a tiny funnel carrying water deep into the core of the wood, where decay can spread invisibly for decades. Medieval builders looked at this problem centuries ago and simply said, "Why use metal at all?" So they built entire cathedrals, halls, bridges, and homes using almost no iron fasteners whatsoever. Instead, they used wooden pegs called trenails or tree nails. And this is where the genius appears. The pegs were intentionally made from wood drier than the surrounding beams. Why? Because once humidity increased, the pegs absorbed moisture and expanded outward, locking the joints tighter and tighter over time. Modern nails loosen as structures age. Medieval wooden pegs strengthen themselves naturally with changing seasons. It's almost absurdly elegant. Then came scarf joints, dovetails, lap joints, mortises, tenons, an entire language of interlocking geometry designed to let buildings hold themselves together through compression rather than brute force. Some scarf joints actually became stronger under heavier load. The greater the roof weight pressing downward, the tighter the connection squeezed itself together. Imagine designing a structure where stress improves stability instead of destroying it. Modern engineering often fights forces. Medieval joinery redirected them. And perhaps the most astonishing advantage appeared during earthquakes and structural movement. Medieval timber frames flexed. Slightly, yes, but enough. Since the joints weren't rigidly frozen together with glue and metal plates, the entire structure could absorb energy dynamically. Buildings bent, shifted, and settled instead of snapping catastrophically. Many surviving medieval timber buildings in seismic regions owe their survival to this flexibility. Meanwhile, modern rigid systems often crack under the same stresses because strength without flexibility eventually becomes brittleness. Think about how strange this is historically. We often assume modern engineering automatically surpassed everything older. Yet some medieval structures survive earthquakes, storms, and centuries of settling better than many modern buildings assembled with industrial materials and computer modeling. And maybe the deeper lesson here is psychological as much as structural. Medieval joinery accepted movement as inevitable. Modern systems often try to eliminate movement entirely, but nature always moves. Wood swells, foundations settle, wind pushes, temperature shifts. Medieval builders created systems capable of adapting gracefully instead of resisting absolutely. Their buildings survived not because they were rigid, but because they were allowed to flex without breaking. A medieval timber frame behaves almost like a living skeleton, compressing, relaxing, shifting microscopically across centuries while remaining intact. And all of it achieved with geometry, patience, and understanding of materials rather than industrial force. No glue, no steel brackets, no electric drills, just wood understanding wood. Medieval builders understood something modern lumberyards almost completely erased. A tree is not one material. It is two. The dark center of the trunk, the heartwood, and the pale outer rings, the sapwood, behave so differently that medieval craftsmen treated them almost like separate species entirely. Heartwood was prized above everything else because it represented maturity. Over decades, the tree slowly filled its core with tannins, oils, resins, and defensive chemicals designed to resist insects, fungus, and decay. Sapwood, meanwhile, was the active living layer carrying nutrients and moisture upward through the tree, which means sapwood was delicious to beetles, fungi, mold, and basically every organism trying to destroy timber. Medieval builders knew this from experience long before microscopes existed. So they removed sapwood obsessively from structural timbers. Entire outer layers were cut away and discarded even though it meant throwing out 30 or 40% of each log. To a modern industrial sawmill, that sounds financially insane. To medieval craftsmen, it was non-negotiable quality control, because the difference in durability was staggering. Heartwood from the exact same oak tree could resist decay 5 times longer than adjacent sapwood. Same forest, same harvest, same beam. Completely different lifespan. Modern lumber production usually mixes both indiscriminately because maximizing board footage matters more than maximizing longevity. And this is where medieval building reveals something deeper than craftsmanship. It reveals values. Medieval carpenters accepted waste in exchange for endurance. Modern industry often accepts shorter lifespan in exchange for efficiency. We optimize yield. They optimized survival. Even moisture behaved differently between the two wood types. Sapwood absorbed water rapidly, expanded unpredictably, and created ideal conditions for fungal invasion. Heartwood resisted absorption naturally. Medieval builders understood this almost emotionally. They trusted heartwood the way sailors trust old rope. And here's the part modern people rarely consider. Medieval craftsmen expected future generations to inspect their work. They carved assembly marks into beams, signed hidden joints, left behind systems future builders could understand centuries later. Some cathedral timbers still contain carpenter marks readable today, guiding restorers through structures built before modern English even existed. Imagine the mentality required for that. These men weren't building disposable products. They were participating in continuity. A carpenter shaping a beam in 1280 knew someone in 1680 might examine his work directly. So quality became reputation extended through time itself. Guild systems reinforced this mentality brutally. Master craftsmen guaranteed work personally. If your structure failed, your name failed with it. Entire livelihoods depended on durability. Modern warranties expire in decades. Medieval reputations lasted generations. And perhaps that's the most important thing we lost, not merely techniques, but accountability stretched across time. Modern construction often assumes replacement is inevitable. Medieval builders behaved as though replacement itself represented failure. That difference changes everything. It changes how carefully you select materials, how slowly you work, how much future uncertainty you prepare for. Medieval structures were routinely oversized 30 to 50% beyond calculated needs because builders couldn't predict wars, earthquakes, or future modifications. So they built reserves into everything. Safety margins became acts of humility toward the unknown future. Today, many buildings are engineered toward minimum acceptable lifespan because economics reward speed more than permanence. And maybe that's why standing inside a medieval timber hall feels different psychologically. You're surrounded by evidence of people who built expecting centuries. Their beams carry patience physically inside them. Their joints carry foresight. Their craftsmanship carries responsibility toward people not yet born. These structures survive not simply because medieval builders were clever, but because they believed durability mattered morally. They built as though the future deserved inheritance, not replacement schedules. And honestly, looking at the state of so much modern construction, maybe that's the real lesson hidden inside these ancient beams. We didn't merely lose old woodworking knowledge. We lost the cultural willingness to build things meant to outlive us. There's a strange irony hidden inside medieval timber buildings. Many of the kingdoms that built them are gone. Their borders vanished. Their rulers are dust. Their languages evolved into forms those original craftsmen would barely recognize. And yet the beams remain, quietly holding roofs overhead century after century while entire political systems collapsed around them. That alone should force us to ask an uncomfortable question. How did people working with hand tools create structures more durable than many buildings produced by industrial civilization? The easy answer is better craftsmanship. But that's too simple. The deeper truth is harder to hear because it points directly at modern priorities. Medieval builders worked inside a culture that accepted slowness as part of quality. Time itself was considered material. Drying wood for decades wasn't inefficiency, it was preparation. Choosing the perfect tree instead of mass harvesting wasn't waste, it was responsibility. Oversizing structures wasn't overengineering, it was humility toward the future. They built with uncertainty in mind because they understood something modern systems often forget. Nobody truly knows what the next century will demand from a building, so they prepared for more than calculations required. And this mindset changed everything. A cathedral carpenter knew his work might shelter generations of people he would never meet. A village builder understood that if his roof failed during winter, entire families could die. Construction carried moral weight because failure carried human consequences. Today, many structures are designed around minimum code compliance and projected replacement cycles. Entire industries quietly assume demolition as part of the life cycle. Medieval builders saw demolition as tragedy. Something had gone wrong if a structure failed prematurely. Even repairs were treated differently. Medieval buildings were designed to be maintainable. Individual beams could be replaced. Joints could be accessed. Systems could evolve without destroying the whole structure. Modern buildings often trap vital components behind sealed walls and disposable materials that force complete replacement instead of repair. We build assemblies. They built organisms. And maybe that's why ancient timber halls feel strangely alive when you stand inside them. The beams aren't sterile. They twist slightly, settle subtly, creak during storms, expand during humid summers. Medieval builders allowed structures to participate in nature instead of trying to isolate them from it completely. Modern construction often treats natural movement as failure. Medieval construction treated movement as conversation. But perhaps the saddest part of this story is that we didn't lose these techniques because they stopped working. We abandoned many of them because industrialization rewarded speed more aggressively than permanence. Faster harvesting, faster drying, faster assembly, faster profit. The economic system changed first, then architecture followed. And to be fair, modern engineering solved enormous problems medieval societies couldn't touch. We build skyscrapers, bridges spanning miles, earthquake-resistant towers, climate-controlled interiors. But somewhere during that progress, we quietly accepted shorter lifespans for ordinary structures as normal. Disposable culture reached architecture too. Yet those ancient beams still stand there challenging us. Every medieval roof frame surviving after 700 or 800 years acts like silent evidence against the idea that modern always means superior. Sometimes progress solves problems while simultaneously creating new ones. And perhaps that's the real reason these old timber structures fascinate people so deeply today. They represent continuity in a world obsessed with replacement. They remind us that human beings once built not just for themselves, but for descendants centuries away. And maybe that's the lesson hidden inside every surviving medieval beam. Durability is never accidental. It's the physical result of patience, responsibility, restraint, and respect for materials greater than immediate convenience. The wood lasted because the builders thought beyond themselves, and perhaps civilizations survived the same way. The story of medieval woodcraft is not really about wood. Not entirely. It's about time, responsibility, patience, and the uncomfortable truth that durability is often the enemy of speed. Medieval builders lived in a world without modern machinery, industrial supply chains, engineered adhesives, or computer modeling, yet many of their structures continue standing after 800 years because they approached building differently at the most fundamental level. They studied materials instead of forcing them. They observed nature instead of assuming they had conquered it. They accepted waiting as part of strength. A tree wasn't just lumber to them. It was a living structure carrying decades of information inside its grain. The moon mattered. Seasons mattered. Airflow mattered. Drying mattered. Species mattered. Moisture mattered. Everything mattered because future generations would physically live beneath the consequences of those decisions. Modern society often measures success through speed, convenience, and scalability. Medieval builders measured success through endurance, and maybe neither system is entirely right or entirely wrong. We have achieved extraordinary things with modern engineering, but these ancient timber halls, churches, bridges, and homes still whisper an important warning across the centuries. When profit outruns patience, permanence disappears. The reason those beams survived is not because medieval people were magically wiser or more virtuous. It's because they were forced to think long-term in a world where replacement was difficult, expensive, and sometimes impossible. They built as though the future mattered because survival demanded it. And standing beneath those ancient roofs today, looking up at wood shaped by hands dead for centuries, you realize something strange and deeply human. The greatest structures are never merely constructed. They are inherited.